Hello. We're looking at 6.2 in this video. Welcome back. If maybe you're watching two videos in a row and you just watched the 6.1, I'm wearing the same thing. This is moments later. I'm recording this one. So let's jump straight into it. No dilly-dallying. Once again, in this video, there will be questions that you will need to answer along with it. If for some reason you're not seeing the questions, then you probably clicked on the wrong link or something like that. Just to let you know. Okay. So, yeah, let's jump right into it. So today we're shifting gears a little bit and looking at statistics. Again, let's hope this video is 20 minutes or less, just like the last one. So we have a lot of just definitions, and I'm not going to dwell on the definitions because if you aren't 100% certain of something, you can literally just Google these words. Like, in my opinion, there's not much to teach here when it comes to the definitions. If you're unfamiliar with the word, you've got the definition on the page here. You can go look up a couple examples in a dictionary or on Google or whatever, right? But these are the big words that we need to know. So this is a nice list so that you can always refer back to. Okay, but let's hit them each real quick. The data gathering, so a census is the data gathering technique in which all of the population is studied or surveyed. So, for example, the U.S. Census, right? The government or who tries to hit every single person in the United States, they're getting all of the population, the U.S. Census. That's an example. Convenience sampling, a sampling method in which the individuals are selected based on how accessible they are. So convenience being the key word here, right? We're not going out of our way to ask every single person like a census. It's just who's convenient. So for example, we could take a poll or survey students as they walk. Whoops, I can't spell walk apparently. As they walk in the school building. So let's say we were actually at school, right? Does everyone walk in the same door? No. Does someone get there before me? Yes, of course. I'm just going to show up at 6:45 and ask the first 15, the last 15 minutes worth of kids who walk in the building. Did I ask everyone? No. Did I go out of my way to find anyone? No. It was just who was convenient. A comparative study in which the researcher imposes, so an experiment is a comparative study in which the researcher imposes some treatment in order to observe a response. So something that comes to mind for me when I think of an experiment is, say, pharmaceutical testing, right? When they're testing out a drug, right, of some kind. For example, maybe they're testing out a new kind of birth control. Maybe they're testing out some sort of pill that helps reduce hair loss. Maybe they're, for example, the testing they did for the COVID-19 vaccine, right? Stuff like that. They're obviously imposing a treatment and studying the results. Interquartile range. I'm not really going to come up with an example here. You just need to know what this is. When you have a box and whisker plot, which you've seen before in the past, probably in like 6th or 7th grade, this is called Q1. That number right there, and that's called Q3. The interquartile range is Q1 minus, or sorry, not Q1, Q3 minus Q1. We'll use it here in a bit. Mean, that's a fancy word for average, right? It's a fancy word for average. So the sum, you add up all of the test scores, for example, and divide it by the number of students there are. I would get the average or the mean. So average test scores, why not? That's an example. Observational study. So compare this with an experiment, okay? Compare and contrast the two. So a comparative study in which the researcher tries to gather data without influencing the response. So we are not imposing a treatment. We're just standing back and observing. Okay? So you might, observe a dog's behavior. Observe a dog's behavior when left alone with food, right? You've probably seen YouTube or TikToks or whatever where it's like they set up the camera and they leave this like juicy steak in front of the dog, and the dog just is like, whimpering because they want to take it, but they don't want their mom or dad to be mad at them, so they just like suffer, right? And they're like, what are they getting back, right? We're not imposing a treatment, right? We just left the dog in a room and said, okay, what are you going to do, right? That's an observation. Parameter, a number that summarizes a characteristic of the population. So a number that summarizes a characteristic of the population. I want you to compare this with a statistic. You've probably heard, the statistics show. Well, give me a sec here and let's jump down to statistics. So a number that summarizes a characteristic of the population, whereas a statistic is a number that summarizes a characteristic of a sample. Okay, so even before I answer those two, sorry, I'm jumping around, but I'm just kind of realizing that, it's probably better if we talk about population first. What is a population? A population is the entire collection of people from which we may collect data. So, for example, all juniors at DO. A population can be anything. I might want to study the juniors at DO. So therefore, every junior at DO is the population, and my sample might be you guys. Right? Most of you are juniors. So, do you represent the entire class? Well, I'm using you as a sample to help roughly estimate what the results of all juniors might be. I might say, well, my students got an average of a 27 on the ACT. I'd estimate that all juniors at Desert Oasis will get a 27, right? You can have your own opinion whether that's a good study or not. That's not the point, right? Population is the big group where sample is the small group. But let me switch gears on you. What if the population is all juniors of Clark County School District? Well, then the juniors at DO could be considered a sample. It's about what you want to study, right? It's not like juniors at DO is exclusively a population. No, that's only if I want to study the juniors at DO, right? But if I want to study all juniors in Clark County School District, well, then the juniors at Desert Oasis have become simply a sample, because that's not the entire population. It's only part of it, hence a sample. Hopefully you see where I'm going with that. So, parameter versus statistic. Well, a parameter is a number that summarizes the entire population, where a statistic is something that describes the sample. Okay? So, a parameter might be average ACT score, to go with what I was saying, of all DO juniors. That describes the entire population. But a statistic would be, the average ACT scores of my class. My class meaning me. You can write Mr. Skis if you want. The average ACT score of Mr. Skis' class, right? You guys. So, hopefully you see what I'm getting at here, okay? Percentile. I think that's supposed to be percentage. Percentage? The percentage of data that fall at or below an observation. For example, a free throw percentage, right? Something like that. Or you might have you've probably taken some standardized test and you got some like report back and it said like, you're in the 95th percentile. Have you heard that before? Probably. That means that you are better than 95% of all the other students that took that same test. That's what 95th percentile means. It means you're that means how many people are behind you, okay? Random sampling. So we had convenient sampling, the kids just casually walking in the door. Random sampling is a sampling method in which each individual in the population has an equal chance. The kids walking in the door didn't have an equal chance, right? I might have been standing where the bus doors are, right, in the school building. But what about all the kids that just walk in the front door because they just walk to school or something, right? Boom, right? They don't all have an equal chance of being chosen. Random sampling, they do. So how about names from a hat? I put every one of your names in a hat, and we pick at random. Self-selected, a sampling method in which individuals volunteer to be part of a sample. So one of the things that came to mind for me is feedback surveys at a restaurant. Right? Like, especially, if you go to a place that has those little kiosk things, right, where you just pay with your card at your table, and then it asks you like, hey, do you want to take a quick 1-minute survey, right? No one's forcing you to do that. You are selecting yourself by accepting that, okay? Standard deviation is the typical difference between each data value and the mean. Now, that's sort of an upper level thought, but you might see like, oh, the approval rating of our president is 40%, and then they might have a little number afterwards, plus or minus 3%. Another way to think of it is like margin of error. You've probably heard that phrase, right? That's sort of what standard deviation is. So it's this boundary like above or below, like within reason, right? It's like 40% plus or minus a smidge, right? That smidge is the standard deviation. Don't worry about it too much, okay? Systematic sampling. So convenience, self-selected, random. Lastly is systematic. So there's a clear-cut system. So how about, I know that every single one of my students is going to walk in the door, right? If we were in class, right? So I might survey every 5th student, right, who walks in the door. Right, that is a system, right? It's not everyone, and it's not exactly random. There's a pattern to it every 5th student. Z-score, it's just a number that you can't really give an example for it. We'll use it later. I'm not really worried about it right this second. Okay, so that was 12 minutes of definitions. If there was any example that you are uncertain about, or definition that it didn't quite jive with you, go back, rewind, listen to what I had to say, or just Google it, right? And just Google examples of statistics, examples of systematic sampling, right? You will find an abundance, right, if you were uncertain of any of those, okay? So identify the sample and population. And again, to go back to my definitions, population is the big group, sample is the small group, right? Think of it as, here's population, sample is just a little piece of that, okay? A truckload of pears arrives at a fruit production plant. The plant's quality control team selects 4 large buckets of pears from various locations within the truck. These pears are carefully inspected. Based on inspection results, the entire truckload is either accepted or rejected. So they're not looking at the entire truckload. The truckload is the population. But they're basing the quality of these pears based on the 4 buckets that they choose essentially at random. Okay? So that's the sample. You got a giant truckload. You can't inspect every pear. So they're going to take 4 buckets and they're going to go, yeah, these look good, so I bet the truckload's good. Sample, population. Different types of writing can sometimes be distinguished by the lengths of words used. A student interested in this fact wants to study the lengths of words used by J.K. Rowling and her Harry Potter books. She opens a Harry Potter book at random and records the lengths of the first 250 words. So a student is interested in this fact and wants to study the lengths of words used by J.K. Rowling. So the population is J.K. Rowling's words, right? She's written a lot of words in a lot of books. So that's what the student wants to study, and they pick at random The first 250 words on some page. So that's their sample. In no way did this student read every single book and record the length of every single word. That would take nearly forever. So they chose one random page and took the first 250 words. That's the sample. So the population is the big group, the sample is the small group. Continuing on. Determine if the following situation describes an experiment or observation. Go back up to the definitions if you need to. What was an experiment? What is an observation? Experiment is when you impose a treatment. Observation is when you just, well, sit back and observe. In 2001, researchers announced that children who spend most of their time in childcare are 3 times likely to exhibit behavioral problems in kindergarten as those who are cared for primarily by their mothers. When I read that, I don't know about you, but I just sit back and go, oh, well, the kid just lived their life, and researchers just sort of observed what happened to those students. They didn't say, okay, we need to give these students this specific type of this, or right. It was just, okay, they had this group of students or kids, and some of them went into childcare, some of them hung out with their mom. What happened, right? So it's an observation. There was no treatment. Okay. I've realized that I haven't asked a question. I don't really have a question to ask yet, so we'll see if I have a question. Before a new variety of frozen muffin is put on the market, it is subjected to extensive taste testing. People are asked to taste the new muffin and a competing brand and to say which they prefer. Okay, I don't know if you already can guess it, but this sounds like an experiment to me, right? These people are specifically being given a muffin, right? As weird as it sounds, that's a treatment, right? These people would have never had these muffins, right? If the person didn't give it to them, right? This is a new muffin that they're testing, right? They didn't just go out in the world and observe people eating their muffin, right? It doesn't exist yet, right? They're trying to compare and to contrast. They've given them the treatment of muffins. I know that seems goofy, but I hope you see the distinction between the two. If not, you can always ask in class. Okay, we can make up a few more examples. Okay, so how about I have a question here for you, right? Parameter and statistic. That's dependent upon the population and sample. So we already talked a little bit about population and sample. I want you to tell me, let's read the question, and then we're going to have a question on the screen here. You tell me which one's the population, which one's the statistic. So on Tuesday, the bottles of tomato ketchup filled in a plant were supposed to contain an average of 14 ounces of ketchup. Quality control inspectors sampled 50 bottles at random from the day's production. These bottles contained an average of 13.8 ounces of ketchup. So, okay, here's the question. What is the population? Okay, so you answered the question. The population here is the total, on Tuesday, the bottles of all of the bottles that were filled in a plant, right? That is the population. There were a bunch of bottles of ketchup created, but the inspectors simply sampled 50 bottles. So there were thousands of bottles made, but they sampled 50. So what is the parameter? Parameter, if we go back up, remember, is a number that describes the population. Okay? So the parameters are, and you've probably heard that word before, they set forth these parameters. You need to do this. Well, the parameters that are set forth for this plant is that we need to have 14 ounces in each bottle. Those are the parameters. But when they tested it, they had 13.8, right? They sampled 50 bottles, and those bottles averaged 13.8. Pretty close, right? It's not like it can be perfect. Or maybe it can, I don't know. Okay, so again, what is the population and what is the sample here in option B? On a New York to Denver flight, 8% of the 125 passengers were selected for a random security screening prior to boarding. According to the TSA, 10% of airline passengers are chosen for random screening. So the TSA states that the parameters, when you come in to a flight into the airport, the likelihood that you are chosen for a random screening is 10% of all passengers. That is the parameter. But on a given day, on a given flight, only 8% were chosen, right? That's a sample, right? That's not every single flight that occurred. That's just one specific flight. Right? So 8% on that flight, but in general, they say 10%. So the in general is the big population. That specific occurrence is a sample, so that's a statistic. All right, last set of 3 here. And let's have one more question pop up on the screen for you. Determine if the following situation describes a convenience, random, self-selected, or systematic. These are going to be quick. Convenience. You know what that word means. Random. You know what that means. Self-selected. You know what that means. Systematic. There's a system to it. On a hot Saturday afternoon, Swirl Me, a new frozen yogurt shop, decides to ask every third customer. I don't know about you. That sounds like a system to me. That sounds like a pattern. There's a pattern, right? That makes it systematic. A clothing manufacturer interviews mall patrons and asks what their favorite clothing store is in the mall. That seems convenient, right? They're asking mall patrons. They didn't do anything difficult. They're like, all right, let's just go stand outside of our store and ask people as they walk by. Pretty convenient. Mr. Jones decides who will present their PowerPoint presentation by putting his students' names in a hat. I use that as the example of random. A sports radio station has listeners call into their question. Has listeners call in. Sounds pretty self-selected, right? They are choosing to call the radio station. And I forgot to ask a question. Shoot. What's my question? Okay, let's have a survey. Just answer this question. Let's survey. What's your favorite color? Boom. Thank you. All right. Just to have that one last question in there. So I'll just have a list of colors and you'll choose. So thanks for watching. 22 minutes, slightly longer than the last one, but that's okay. Not too bad. All right. I'll see you.